Now let's actually learn how to use Excel to run one of these tests. So this time we're going to let mu be the mean simulated pitch speed. So we've been using this column C, now we're going to use column D, and we're wondering, is the mean simulated pitch speed different than 75 miles per hour? Let's first make a graph. So let's insert a box plot. So there we have our box plot of the simulated pitch speeds. And let's go with the label over here. And so these are speeds in miles per hour. And we don't need a title here, we just have one box plot. Okay, let me just make it slightly more pretty. I will go to the paint with the border and put a nice border. Okay. And I have it automatically is showing the mean, which actually looks very close to the median. And the question is, do we think that the mean, so where the x is different than 75? We'll see how like symmetric this looks. And here's 75 up here. I actually think that the mean is lower than 75, which, by the way, it's illegal. You don't look at the data and then make your hypotheses. You make your hypotheses based on things that you think might be true from before you look at the data. So we will have already chosen our hypothesis before we do this. But this is just, B is sort of after the fact. So we wonder, is the simulated pitch speed different? So that's going to be this one, our two-tailed test. But I actually think when I look at this data that we're going to reject that null hypothesis, because I do believe it's different than 75. It looks quite a bit down here lower. So do we think that we will reject the null hypothesis? Yes. Box plot suggests we will reject the null hypothesis. Because the mean, and I'll put and median, both look to be less than 70 miles per hour. Okay, so is our test one-tailed or two-tailed? It's two-tailed because of the not equal to. Now we need to get the test done. Okay. I'm going to move this down a little bit. Now, here's how you do a test. You go to the Data and Data Analysis button. And there's all these tests, and we're going to focus on these t-tests. We'll be using all three of these t-tests. And we just want a t-test for a single data set, but Excel does not have that. It only looks at two data sets, which is a bit annoying. So we're going to have to manipulate. The way that you manipulate, and it's not hard to manipulate, which is why I'm going to do it with you. Let's make a dummy second variable and just put a couple of zeros in there. That's all you have to do to manipulate. So let's go back to the test, Data, Analyze. We're going to do a two-sample test, unequal variances. This is what we're going to use to manipulate the one sample test. Okay, where is the variable that we're looking at? It's right here. I'm going to select that, and I want to get all the data. You can scroll down, or I'm going to Control-Shift down to get all the data. Okay, now, whoops. Okay, that happened too quick. It's not what I meant. Let me go back, data analysis. Okay, so we did that. Now our dummy variable, we're going to use these. Okay, now what is the hypothesized difference? I think the difference between these two columns, we're hypothesizing it to be 75. Alpha is that 5%. We could talk a lot more about it, but we're not going to in this class. It's our cutoff for if we're going to reject or not reject our null hypothesis. And let's put the data, let's put the output in, we'll put it in G24. Okay, I'm going to overwrite what I have. This isn't supposed to be there. Okay, so there is my output from the hypothesis test. Now, since we had to manipulate, we're going to continue to manipulate. That dummy stuff we don't need. This is not a 2 sample, it's a 1 sample test. We just had to manipulate it. All right, so I'm going to merge this, bold it, put a box around it. Same thing here for the simulated speeds. The simulated speeds are right there. Let me make it bigger. We don't need this. I'm just going to pretty this up. Clear that. Let's put a box around this. Okay. So here is our test information. By the way, the hypothesized mean difference, we don't have a difference that was manipulating it. The hypothesized mean is 75. Okay, now everything else is what we would expect. Okay, now what's of importance here? Let's come back and see what we're looking for. What is the test statistic? The test statistic is our t-statistic, which is negative 14.2. That's crazy big in the negative direction. Remember I said anything that's like bigger than 3 or less than negative 3 means it's very unusual. So it's very unusual that we will have seen this if the null hypothesis is true. The p-value, we are at a two-tailed test, so our p-value is going to be down here. Now, notice this E minus 4. That's scientific notation that means times 10 to the negative 41st. That is such a tiny number. So that is approximately 0. Slightly bigger than 0. Should you reject the null hypothesis? We reject the null hypothesis if the p-value is less than 5%. In fact, the p-value is almost 0. So let's remember what this means. What that means is assuming the null hypothesis is true. Our null hypothesis is right here. So assuming the mean simulated pitch speed is 75 miles per hour. So assuming that, the probability of getting your data, so what is that? About 60, our statistic is about 66.5. So we're at 75. That's our hypothesized mean, and this is 66.5. That's much smaller. So the probability, the mean, the sample mean is less than 66.5, and this is a two-tailed test, so we have to do or greater than, well, the difference between 75 and 66.5 is 8.5. So if you go to your 75 and you add 8.5, we're going to get to 83.5. So the probability the sample mean is less than 66.5 or greater than 83.5. That probability is the p-value about 0. Means if we assume this, it's hardly likely that we will get sample information that we observed. So we're rejecting the null hypothesis, and we're concluding, I don't believe that, I believe this, the mean simulated pitch speed is, we put the word significantly in here to show that we ran a hypothesis test. So we conclude the pitch speed is significantly different than 75 miles per hour. Now, another way that you could say this, p-value interpretation, by the way, is assuming the mean pitch speed is 75, the probability the sample mean is, instead of actually going to those 66 and the 83, you could say more than 8.5 miles per hour from the hypothesized mean. So this actually specifies what 8.5 below and 8.5 above is, or you could just say it's more than 8.5 miles per hour from that hypothesized value.